In this lecture, we're going to look at another example of a case where you might want to set up weak ordering comparison for your custom types. And what we're going to do is a class that is going to do case-insensitive comparison for strings. And we are going to be smart about how we name it. We're going to name it case-insensitive string. How cool is this? So we're going to set up two objects of our class. One is going to say hello. The other is going to say hello in all uppercase. And we're going to consider these two strings equivalent because they convey the same message. But deep down, they are going to be really different. So they are not absolutely equal because they don't have the same set of characters inside. So we don't want to do strong ordering, which string does by default. We want to do weak ordering here. I hope you understand this. So try to think about how you would implement a class like this. My take on this, I am going to do a simple function which is going to do case-insensitive comparison on two C strings that we pass it as parameters. I am going to call it case-insensitive compare, and I am going to set up two strings that are going to store copies that we turn all to uppercase, because that's going to give us common ground to compare them as if they are the same thing. And after we have copies of these C strings in these string objects, we're going to loop around each one, turning each character into uppercase using the toUpper function that we have in the C++ standard library. We're going to do this on the first string. We're going to do this on the second string. And at this point, we will have uppercase data stored in these two strings. Now we're going to compare them using the compare method we have on the string class. We're going to say string1 compare to string2. And then if we get a positive value here, we know that string1 is greater than string2. We're going to say that here. If we get a 0 out of this comparison, we're going to know that they are equal. We're going to return weak ordering equivalent. And if we get a value that is less than 0, we're going to know that string1 is less than string2. And then we're going to return weak ordering less. Now that we have this function in place, we can use it in our case-insensitive string. The class is also going to be wrapping around std string, nothing new here, but we're going to be doing a completely different kind of comparison. We're not going to be comparing based on the size of the string like we did in the last lecture. We're going to be comparing strings regardless of the case the characters are in. So it doesn't matter if the text is in uppercase or lowercase. We're going to consider things equal if the message is the same. If we have hello and hello, it doesn't really matter if some characters are uppercase or lowercase. We're going to consider them equivalent. And note that they are not going to be absolutely equal. In this case, we are just interested in equivalence. So we're going to be basically calling our case-sensitive compare function here, and we're going to go to the C string representation of the data that we have in the string. We're going to use the cstr method. You already know this method from a chapter we have done before. And we are also going to grab the C string in the second string that we pass to this operator, and then we're going to compare. The return value of this function is going to be forwarded to the return value of our three-way comparison operator, and we are going to be comparing our parameters here. We are also going to put in a novalode of the three-way comparison operator that is going to be comparing to a const char pointer, and we are just going to call the same method, but we're going to pass the second parameter directly as a C string. You should notice this here. We are also going to use the same function to set up an equals operator. We're going to call our case-sensitive compare function. We're going to pass it the C string inside the current object, and then we're going to compare to the C string inside our right operand. We're going to compare this, and we're going to see if the return value is equal to weak ordering equivalent. If we get equivalent, we're going to return true, and we are going to know that they are really equal or equivalent. If we don't get equivalent out of this function, we're going to know that they are not equivalent, and we're going to return false here. Once we have this in place, we can really use it in our code. We can set up two strings, we can put in whatever data we want, and we're going to see if they are equivalent or not. Please note that because we have a three-way comparison operator which is going to be comparing with the C string, we can use our class with implicit conversions from C strings, as this is going to work really well. This is going to be using the rewrite rules we already know. If the compiler sees that it can't compute things right away, it will try to rewrite the operands using these rules, and it's going to try and order things in a way that makes it convenient for the compiler to call our three-way comparison operator. And this is going to be really cool. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is zooming on weak ordering example 2. We're going to grab our template files and we're going to copy everything and put that in our current project. We are going to open this in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We are going to clean up a little bit and we're going to remove what we don't need here. We are going to include our string class because we're going to be wrapping around an std string. Let's do this. So string here. And we are going to put in our function, which is going to do case insensitive comparison on two C strings. We're going to pass in our C strings. We're going to turn them into std strings because we want the convenience to call compare here. We also want it to be a little bit convenient to turn them to uppercase using the toUpper facility we have in the C++ standard library. That's why we are doing that here. And it is really convenient to loop around this using a range-based for loop here. This is better. Okay, so we're going to have copies in our std strings. We're going to loop over each and turn each character inside to uppercase. And by the point we hit line 18, the data we have in our strings is going to be all uppercase. Once we have this, we're going to compare string 1 to string 2. And the result of our comparison is going to be stored in CMP here. We're going to check and see if CMP is greater than 0. If it is, we're going to know that string 1 is greater than string 2, so we're going to return weak ordering greater. If we have a 0 inside the CMP, we're going to know that they are equal or equivalent. That's what we return here. And if neither of these first two cases is true, we're going to know that string 1 is less than string 2, and we're going to return std weak ordering here. And again, the reason we are doing weak ordering is because we want to really consider equivalence in our class. We don't care too much about absolute equality. If two things are equivalent in that they have the same data inside, regardless of the data is in uppercase or lowercase, we're going to consider them equivalent. That's why we are using weak ordering here. Now that we have the function n, it is going to reliably return a value of weak ordering type, either greater, equivalent, or less. We're going to set up our case insensitive string. The class is going to be ridiculously simple considering the knowledge you have now. It is going to be wrapping around an std string, and we're going to put in two operators, a three-way comparison operator which is going to be overloaded to take a C string as a second parameter. And in the bodies of our function, we're just going to delegate the heavy lifting to compare things on our case insensitive compare function here. So for our operator comparing to a case insensitive object as a second operand, we're going to call this and pass the underlying C strings because our case insensitive compare function takes C strings. That's why we are saying .cstr here to grab the C string that std string itself is wrapping around. We're going to do the same thing for the second operand, and that's what you see right here. And this is going to return the result of our comparison, either std weak ordering greater, equivalent, or less. The second operand is also going to do the same, only now the second operand is a C string, so we don't need to go through the cstr method. The operand is already a C string, and we pass it directly to our case-insensitive compare method here. We are also going to set up an equals equals operator, which is going to be comparing to an object of case-insensitive string. We are going to compare our operands, and if they are equivalent, we're going to return true, which is what we return here. If they are not equivalent, we're going to return false, and we are using a ternary operator here to not have to do a lot of if and else's, and this is going to make things a little bit easier to handle here. Okay, so now that we have our class in place, we can go in our main function and create objects of it. We're going to put in hello and hello, and we want to see that they are equivalent. We should get that they are equivalent. If we try to call the equals equals operator here, we're going to see that they are equivalent, but we can also see that one is less than another, and we're going to see this relationship printed out on the console here if we run our program. We're going to build it with GCC first to see if it works. The build is good, so this is good news. We can clear and bring up a PowerShell window to run this. We're going to run our program, and we're going to see that less than or equal is going to return true because they are equal, so this is going to be good. And equals equals is also going to give us true. This is what we expect here. If we put in a z, for example, they are no longer going to be the same because we have a z in here. And if we build, we're going to see that the build is good. We can clear and run Rooster. Now we're going to see that the string in CSTR1 is less than what we have in the second string here, because we are doing alphabetical comparison, and in the second one we have a z, which is considered greater than the h we have in string 1. And this is going to be doing what we want, case-insensitive comparison on strings. And notice what we just need to do to make this work. We have a bunch of operators in here. This is going to work really well. This is going to also work if we use C strings directly. For example, we can take this and modify it to work with C strings on either side of the comparison operator. We can do this. We're going to also copy this again, and we're going to put that down here. And we're going to take out these spaces we don't want. And we're going to be comparing, for example, to what will we be comparing to? Let's say Kelo. Let's say Kelo here. You can say that. And we're going to pass in a C string that says Kelo. Let's do that. And we're going to pass the C string in the first position here. So we're going to say Kelo, and we're going to pass Kelo in the first position here. And you see that we don't have any squiggly lines because our three-way comparison operator that takes a C string is going to be flipped around. The compiler is going to flip things around and try to find an arrangement that calls the three-way comparison operator with a case-insensitive string object on the left, and this is going to work really well. So let's try and build and see what we get. We're going to see that the build is going to be good. We see that here. We can clear and run Rooster. We're going to see that the string in string 1 is less than Kelo because h comes before k, so k is going to be considered greater than h. That's what we see here. And if we compare Kelo to the string we have in string 2, this is going to be true because k comes before z, which we have in Zillow here. And Zillow is going to be greater than k. That's why we have the arrangement we have here. Kelo is less than Zillow, and this is going to say true. I hope this makes sense. And after that, we're going to compare using equals equals. We're going to get false because the data we have in string 1 is not equal to the data we have in string 2. This is going to work as we expect. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see an example that really tries to display STD partial ordering. Go ahead and finish up here and meet me there.